So let's go back to our polynomial regression model, and here let's select these two columns we are only interested in. So to do this, we will reset the data set. So I'm taking my data set here, and again I'm taking my data set, then brackets, and in this brackets here we will input the indexes of the columns we want to keep to train our machine learning model. So let's see what these indexes are. Okay, so we have three columns. Indexes in R start at 1. So this column has index 1, this column has index 2, and this column has index 3. So since we want to keep these last two columns, then we want to keep the indexes 2 and 3. Okay, so let's input that. To input this, we can simply input to column 3. Let's check it out. Let's select this line and execute. And as you can see now, our data set, if we look at it, only has these two columns, level and salary. So as a reminder, level is the independent variable and salary is the dependent variable. So we will use the correlations between the levels and the salaries to train our nonlinear machine learning polynomial regression model to predict some new salaries, such as the salary associated to a 6.5 position level. Okay, so let's go back to the polynomial regression model. Our data set is well imported now, it's well prepared, we have everything we need, and now let's move on to the next step. So the next step is to split the data set into the training set and the test set, and actually this time, and only this time, we will not do that. And the reason is that we only have 10 observations here. So this is a very small data set, and by the way, I chose this data set because we're still shaping our intuition of machine learning, we're still learning the basics of machine learning, and therefore I choose this simple data set because we have 2 dimensions here, so we will be able to plot the form of the polynomial regression model itself, as well as the future nonlinear regression models. Okay, so let's go back to our model, and as I just said, we won't need to split the data set into the training set and the test set. So what I'm going to do now is I'm going to put all this section in comments. So let's do this. Press Command or Control plus Shift plus C, and that puts all your selected lines in comments. So no training set and no test set will be created. Okay, and the last step now is feature scaling. And the good news is that we won't need feature scaling either. And the reason is simple, it's that because a polynomial regression model is actually a multiple linear regression model with polynomial terms. You know, instead of having different features, like features that represent something very different, we are taking a first feature, which is actually the position levels from 1 to 10, and as the other independent variables that will be in our multiple linear regression model, we will take the squares and other exponents of these levels here. Okay, so actually that's done. That was actually very simple. No need for training set or test set, no need for feature scaling, just some little changes in the data set here with the indexes, and we're all fine. We're ready to build our first nonlinear regression model, that is the polynomial regression model, and that's what we will be doing in the next tutorial. So I look forward to creating this bluffing detector with you, and until then, enjoy machine learning!